Show that P3, m minus 5 is the point of trisection of the line joining the points A4, minus 2 and B1, 4. Hence, find the value of m. So, given A4, minus 2, B1, 4 and P3, m minus 5. So, we need to prove P3, m minus 5 is the point of trisection of the line joining A and B. That is, if we join A and B by a straight line, P is the point of trisection on that line. That means that line divided into 3 parts and the length of the all 3 parts are equal, right? That means AB, that is AB is the line, right? Then there are 2 points on that line P and Q such that, right, AP, the distance AP, the distance PQ, the distance QB, all equal. Then P and Q are called points of trisections, right? Both are called points of trisection, right? So divided into 3 parts, that is why trisection, right? So all 3 parts are equal. AP is to PQ is to QB, it is equal to equal parts 1 is to 1 is to 1. So we need to prove P is the point of trisection. It's a single point of trisection, the line joining A and B. It is enough to prove the part AP is 1 and PB is 2, right? Because PQ, QB. Or otherwise, suppose instead of P you are having Q, then you have to AP is AQ QP, that is 1 plus 1, 2 is to PB, that is 1, right? So other way, so 1 is to 2 or 2 is to 1. If the point divide the line joining A and B in the ratio 1 is to 2 or 2 is to 1, then the point is called point of trisection, right? Right, 1, that is 1, that is 1, that is AB. Suppose you are taking P nearby AB, then 1 is to 2. If you are taking nearby B, then 2 is to 1, right? We know P x, y divides the line joining the points A x1, y1, B x2, y2 in the ratio m1 is to n1. Because you are having already m in the problem, that is why I am taking m1 is to n1 instead of m is to n. Then P x, y, which is equal to P of x coordinate m1 x2 plus n1 x1 by m1 plus n1, and y coordinate m1 y2 plus n1 y1 by m1 plus n1. Here x1 y1 is 4, minus 2, point A, and B is x2 y2, point 1, 4, and the point P is x, y, that is 3, m minus 5. So substituting m1 into 1 plus n1 into 4 by m1 plus n1, m1 into 4 plus n1 into minus 2 by m1 plus n1. We know xy, which is equal to 3, m minus 5, right? So 3, m minus 5, which is equal to m1 plus 4 n1 by m1 plus n1, and 4 m1 minus 2 n1 by m1 plus n1, equating the corresponding coordinates, right, on both sides. So you will get m1 n1 plus n1 4 by m1 plus n1 equal to 3. We are taking the x coordinate only, so we need to find m1 is to n1, that is the ratio. So m1 plus 4 n1 by m1 plus n1 equal to 3. Cross multiplying m1 plus 4 n1, which is equal to 3 into m1 plus n1. So m1 plus 4 n1, which is equal to 3 m1 plus 3 n1. So grouping n1 and m1 one side, so 4 n1 plus 3 n1 on the right hand side becomes minus 3 n1 on the left hand side. which is equal to 3m1 minus m1. That means n1 which is equal to 2m1. So m1 by n1 which is equal to 1 by 2. Therefore m1 is to n1 is 1 is to 2. So we proved the point P divides the line joining A and B in the ratio 1 is to 2. Therefore P is the point of trisection, right? That is 2. So to find the value of m, so from 1 and 2, 1 into, we know m1 is 1 and n1 is 2. 1 into 4 plus 2 into minus 2 divided by 1 plus 2. We are taking the other coordinate, y coordinate, that is equal to m minus 5. That is 4 plus 4, 2 into minus 2 minus 4 by 3, which is equal to m minus 5. So m minus 5 equal to 0. So m equal to 5. That's all. Thanks.